Welcome to another video on my Raspberry Pi 2 running Ubuntu Linux, and for this project programmed in C, C++ and Bash. It's connected to a serial cable, HDMI, although that's for explanation later. Then under here a network cable for VNC and internet access, of course, and a band cable which is connected to this breadboard with some electronics and fischertechnik. Also connected to a MacBook with extra screen. Reason for that is that the backlight of this MacBook is faulty. You can barely see it on here, but in here of course quite clearly, and it's also on VNC. And that is the fourth desktop via VNC. The other one is this tablet, and I will have to hold it like this, otherwise the lamp is coming in. So two screens or two terminals, one for the source code for Bash and one for executing. And with Bash you can do slightly more than with the wiringPi library that I have to use for accessing this via the GPIO, which is here, general purpose input output. So let's first see what I did. I will run the software. First the C++ program, and I have to give this some assistance. Also light for the photo transistor and the button do work now. I can show you soon on screen. And then for the C program, that goes the same way. So should show the same stuff. For some reason red doesn't show. Not quite sure. Let me do that again. No, it doesn't show. More things don't show now. Right. And yes, this one has gone out. And then a demo turns out to be not so demonstrable. That one should be here. Another attempt. Anyway, it does work. So now I'll have to press enter on the tablet. And then this suddenly starts to work. This works. This does work. Anything works except for the LED for some reason. Anyway, I'll show you how it works with the software. So let's go see there. Alright, so I showed you the, the virtual desktop on the Mac. I showed you on the tablet. This is the first desktop with the C++ program, using IOStream for screen output, then wiringPi library for for being able to write and read from the GPIO, and then I have to define which pin is input or output, and you see here 11 and 18 pin and pin number and GPIO, because the wiringPi uses the real GPIO port. And then I go here to the wiring. So GPIO 18 is pin number 12. And let me show you more clearly. So if you count from here to here, which is exactly the same as on the Raspberry Pi itself, of course, then this what you see is 2, 4, 6, 8, etc. So that is the pin number, and it has GPIO 18, and wiringPi uses the real number. Which is by the way not entirely true, because it has its own limited number of pins that that can be used. So while this is exactly true, pin 11 is GPIO 18, it is for wiringPi pin number 1, and so you have to number through. Now this is just standard C++. This right is once again wiringPi delay, then it writes what it is on screen, as you can see here on the other desktop. And then you have digital reading for a button pressed or the phototransistor being lit upon. Here it hasn't been done, but let me run it again, and then I will show this light right here. Run. Why does it say no light? Let's try again. That's not what I want. So this should all be alright. Okay, let's try the button, which is there as well. Pressing the button. Yeah, button pressed, so it does work, just the light doesn't show. The same thing will be for C. But I let go for now. So what was the purpose of this whole experiment, which has lasted for quite a few episodes? Well, basically I started out with ROS, the robot operating system, and there I met the problem that I couldn't control anything at all, and that is in C++ as well. So hence this experiment, how to find out which works and how. So let me go into what exactly, back into Catkin Workstation. But before I do that, is there anything else I can or should try? I'll have to ponder about that. So let's see. Alright, no ROS yet, no robot operating system is yet. I want to first test something in C++, not C right now, because I will use C++ further. What I have done now in the algorithm Let me move this one a little bit down. I have copied and changed things. First of all, now here you see everything in green. I've changed here green into red and here into fischertechnik because that's what they are. Not all LEDs that I use are green. And next I have changed, I have copied fischertechnik here for button pressed and motor for the photo transistor. So now if I press the motor, if I press the button, then the fischertechnik LED will shine again. And if I shine light on the photo transistor, then the motor will run again. That is the idea. So let me first compile. Then press the button. And now I have to be a little bit careful, so not shielding anything, and that is going to be a bit tough. Alright, pressing the button. Run. Right, this is a bit odd, so wait, when I press the button the fischertechnik LED should go again. Now this requires a bit change of algorithm because it goes off and then there's no delay. So what I need to do is making a delay here. So there is 1 second delay before things happen again. And then what I also can do is have this burning a little longer. Let's say 1 second instead of a delay of 500 milliseconds. So 1 second. I have to compile again. Oh, yeah. So that's better. Now it will work. Yes. So now I will press the button again, and I better use it in another way. This way is a bit oh, I can put this as to make it even more clear. Again, so then it is very clear that it is run the second time. That's better. Right, press the button. No, and I will have to use this one. Yes. Yep, and that is it. So that works. And that the LED is not going to work or burn, that is another thing because of the wiring here. Right. Anyway, it does work. So how about with the light? I shine on it, go. Oh, and then I should have set motor again. but it says no light. Let me change first motor again. Compile. So why doesn't the LED, the phototransistor, work? That's annoying. And there's enough light. So try again. Run. No button, no light. Oh, that's not good. Where's most of the light going? There's the most of the light. So let's shine it like this. It's a little bit in an angle. I have to hold it a bit like this. Go. No button, no light. Okay, that's annoying. But the idea is clear. Except that once again this wire is gone. Next is what? Well, now I know that this works. This is also the idea that in ROS should work, but how to implement it, that's another thing. But I want it to shine. So try again. Something is odd, very odd. Alright, on the Mac now, as you can see by the screen, this is the source code that I am now browsing and not editing, because it's open for editing on desktop 1. But the point is that I need to edit here some in the ROS structure. And everything that is over GPIO class can go out. And I have to do it here. Don't forget it is VI that I'm using. All of this can go out, not used. So 22 up to 41, it's about 40 lines. So 40, delete. Is that true? No, way too much. Okay, 5 gone. No. 5 gone. 5 gone. 5 gone, which is 20 lines. So I made the typo. Now the whole thing is I have to put everything in here. This is the control file, or is it? Yes, it is, because here in this one I call the motor. This is the control file. So from here I have to set a pin mode from wiringPi setup. Although the question is, can I really call it through here? I have included it. Or did I? No, I did not. I haven't even included it anymore. So that's what I have to do first. And this sounds a bit clumsy, but first I'm picking up again. And this has to be done for everything in here. So let me see if I can just copy it, saving time. Which is very nice. So now everything is defined. And from here on I have to use it. But let's first deal with something else. Oh wait, I have here the file included. But this is the callback. This is the main. So I should, I think, use this as well. Let me just put it from here in here. Whatever is best will work. What else? Compiling. For that I need to change the settings. And if you followed the entire series on my ROS in the same context, then you know that is quite a tedious job, and not the only one having problems with it. And that worries me very much. So let's just hope for the best. Let's see how. Alright, and now I have come to a pain point. That's really a pain. On when I want to compile my test file, I have to use a lot of links, and you've seen that in the start of this video. So those files are, if I take it back, that is wiringPi link, wiringPi dev link, pthread, something called M, then lcrypt, and real time. The first thing that happens is wiringPi setup. So and that is, yeah, unfortunately part of what I have to edit. So going source, going here, and then I have to go to CMake list. And if you've seen the other videos, then you know this will and can be a pain. Scrolling through these things, through these settings, dependencies. Yeah, what is a dependency anyway? This is for messages. Include directories. Well, this clearly hasn't helped. Because it's telling me that it can't find a reference to wiringPi, but that will be probably then a link problem. And here it is for executables, target link libraries. Right. So if I put something in here, how do I put it? I can, for instance, put wiringPi in here. And I have to do it for control. That's what it is about. So let me just wiringPi. Then I have to link wiringPi dev. Next I have to include, to link p thread, whatever it is, m, whatever it is, crypt, something like cryptography or something, and real time. Will this work? I have no idea. So let's save and go back. I'm here again. Cat can make. Go. If it bombards me with error messages, I have to find out something else. This is all first messages, message generations. It goes to linking. You're kidding me. It says it is done. Really? That's a new one. So that means that I did it right. Well, I can test that with only one thing. Shrinking this first, and then yeah, echo, and then the ROS library pass. But let's just say I did that exactly already. Oh wait, I have to start ROS core, of course. Otherwise I can't do anything. Right. ROS run. Raspberry FT, and then FT control run. That works. So opening a new window, and of course I have to catkin develop, and then setup bash. Right. Yep, and then FT motor. Well, at least this runs. So somehow this does work, whichever one it takes, and this works as well. I just wish I could test it, because that is something I didn't test. I didn't write in yet. But at least it's a start, a nice start. So with this rather positive result regarding the robot operating system, and some nice results here as well with changing this algorithm in C++, although I am not satisfied with this one. why doesn't this work? And maybe if I position it directly, let's try and see, and then I have to be here. No, other tab, like this, go, motor works, LEDs work. Finally, photo transistor, and once again the motor works. That is what I want to see. Very good. As another thing that I would like to use is the serial interface, which I can of course also program in C and C++. Information gathering, not just on screen as you've seen in the previous segment, but also just into a nice data log file somewhere else. So that is another thing, and I can first program and try it in here and then use it elsewhere. So I think a rather nice result. And yes, the schematics stays right ahead, and then this can be used as a separate stuff. Voltmeter, well, no longer really applies, but when I use an oscilloscope I can. Motor works, LED works, anything works. The only thing that I really have to keep in mind is that wiringPi is a bit limited in the GPIO ports on that, because I cannot use the upper ports. The higher number ports I cannot use, and that is just too bad. That limits the number of things I can do, because most of those pins are, according to Raspberry Pi information, pins that I can use. Anyway, we'll see. And with this result, I say thank you for watching. Well, I said it all in the previous segment, so if you like this video, please subscribe to my channel and give the video a thumbs up, leave a comment or suggestion. Please, you can also follow me via Instagram and Twitter. Please show your support by making a donation via either PayPal or Wired, or you can also become a patron and have your name mentioned as a supporter. All information also available via my website, which is listed under this video, as well as always to donate. So this is obviously going to be continued. Have a nice day and bye bye.